Okay, this should be the last one of notes, and we're probably going to have one or two of problems with this chapter too, but this should be the last one for the notes. Okay, so what we're going to do is I'm going to get rid of this. Apparently I'm going to just drag that around a little bit. I'm going to get rid of these notes right here, because we've got a very important piece here, and that says, remember back when we said, okay, what if I have a distribution X and a distribution Y, SAT Math, SAT Verbal, and I want to combine them? What do I do with the means? Well, I can just add the mean from the SAT Math and add the mean from the SAT Verbal, and I can add those means together of those distributions, okay? But we also have a piece of information here that's going to be really, really, really important. I'm going to break this ugly green color. If X and Y are independent random variables, meaning there is no relationship between the two, then I cannot combine standard deviations. And the reason I can't combine standard deviations is because that last step, that square root, that last step of square root screws up the adding of those variables together. So what I have to do is I have to square them first. And this is where the variance part becomes really important. I have to square them first, and then I can add them. And that's what this says right here. This phrase says here, the variance of X plus Y is equal to the variance of X plus the variance of Y. So what I'm going to do, if I want to combine these distributions, I'm going to take, instead of the standard deviation, I'm going to square the standard deviation of the one distribution, and get the variance. I'm going to square the standard deviation of the second distribution and get the variance. I'm going to add the variances together, and that will give me the variance of the third distribution. That combination, okay? But chances are I want that standard deviation. So what I'm going to have to do at that point is I'm going to have to take the square root. And if this looks really familiar to you, it should. Because another way of thinking about this is this. If I would change these two letters and change the variance of X plus Y to C squared, take X and make it an A squared, and take Y and make it B squared, I get C squared is equal to A squared plus B squared. Really what this looks like, it looks like the Pythagorean theorem. And it is. In a respect, it is. It is like the Pythagorean theorem. And what is not unheard of is for people to sit there and think, oh, I've got a distribution that looks like this, and this would be the standard deviation of X, and this would be the standard deviation of Y, and I'm looking for the hypotenuse, which is the standard deviation of those distributions when they're added together. This is the standard deviation of X plus Y. So I would square this, I would square that, that would give me this hypotenuse squared, and then I would take the square root. That is not unheard of to do. Here's the mess with you part right here, okay? Highlighter again. This time we're going to go with this lovely orange here. This statement right here, oh look, that covers that up just completely so that you can't read it. So I'm going to have to write that. Oh, that's fine. What this statement right here says is the variance of X minus Y. So I'm going to subtract these distributions is equal to the variance of X plus the variance of Y. And if we think about this, here's the one problem that we could have. And that is that if I were going to subtract, there's an opportunity there for me to have a negative standard deviation. Can't have a negative standard deviation because standard deviation really is average distance from the mean. So we have to add the standard deviations, or we have to add the variances, which brings us to the lotus position. And we get into the lotus position, and you're going to have to assume that my legs are crossed and I'm sitting here in the lotus position. And, oh, I never started that clock. And the lotus position is like this, and our knees are, our elbows are on our knees or our legs, and we're sitting here like this. And our phrase first is, of course, om, om, and then we say, so that we remember, variances always add. Variances always add. Is that the opportunity for some kind of trick question? Well, not necessarily a quick trick question. Well, maybe even a trick question. But it could mess you up. Be careful with it. Variances always add. Now, the other part of this that could be tricky crap is that they have to be independent random variables. So, say for example, I wanted to take SAT Math and SAT Verbal. I wanted to combine them. Fine, I can add the means. Standard deviations? No. I can't, because those variables are not independent. SAT math and SAT verbal scores are not independent. However, if I want to talk about SAT math and say bowling scores, sure, I could combine them and I could find the standard deviation of those because they are not independent. And is there going to be are you going to have to test for independence, like the probability of B given A is equal to the probability of B? No. It's going to be really a logical thought. Are these two independent of each other? And you would sit there and say, no, these are not independent of each other, therefore I cannot combine the standard deviation. That is certainly an opportunity for that tricky question. Okay, that's it actually for the notes for this section. Let's see about doing some problems, because problems are fun.